In our last lesson, we saw how to lend our variable to a function by reference. Alright, what should we do if we want to change our variable inside the function? Now, we will examine mutable referencing, which is the subject of this lesson. As you can see, we got an error because the variable s and the change function are not designed to be mutable. First, we change the variable s to mute. Next, we need to specify that the change function will accept a mutable reference with &mute, the value entered in its parameter. Yes, we fixed our bug and now we can explicitly say that the change function will change the borrowed value. While we were reviewing the topic of references earlier, we mentioned that mutable references have a major limitation. If you have a mutable reference to a value, you cannot have any other mutable references to that value. There can be only one mutable reference. If we try to create two mutable references to the variable s, our code will fail. This error says our code is invalid because we cannot borrow the variable s using multiple mutable references at once. The restriction which prevents multiple simultaneous mutable references to the same data allows mutation in a very controlled manner. This is an issue that newcomers to Rust struggle with, because most programming languages allow you to use mutation whenever you want. The benefit of having this restriction is that Rust can avoid data races at compile time. A data race is similar to a race condition and occurs when three behaviors that I am going to talk about now occur. When two or more pointers access the same data at the same time. When at least one of the pointers is used to write to data. When there is no mechanism used to synchronize access to data. Data races cause undefined behavior and can be quite difficult to diagnose and fix when trying to track them at runtime. So Rust avoids this issue by refusing to compile code with data races. As always, we can allow multiple mutable references by creating a new scope. The point we want to emphasize here is that simultaneous references are not allowed. Rust follows a similar convention of using mutable and immutable references together. We can't have a mutable reference to the same value while we have an immutable reference. Once a fixed reference is created, the value is not expected to change abruptly. However, multiple immutable references are allowed because just reading the data doesn't have the ability to affect the rest reading the data. Note that the scope of a reference starts from where it was created and continues until the reference was last used. For example, this code compiles because the first println macro, which is the last use of immutable references, occurs before the mutable reference is created. While the scopes of the references do not overlap, so compiling the code is allowed. While borrowing bugs can be annoying sometimes, remember that the Rust compiler signals a potential bug early and shows you exactly where the problem lies. You don't need to figure out why your data isn't getting the results you thought it would, since we learned about the error at compile time, not runtime.